This is Dr. Anima Upadhyay, and in today's lecture, we'll discuss the various methods employed for the control of the electrochemical corrosion. In my previous lectures on the electrochemical corrosion, we have discussed about the types and causes of corrosion, specifically the electrochemical corrosion and its types and the factors that affects the rate of electrochemical corrosion. So now we have the entire knowledge, and now we can discuss the methods that are employed to prevent the electrochemical corrosion, and such methods are called control methods. In this chart, I have put all the methods which are employed to control the electrochemical corrosion. The selection of materials which plays an important role in the control of corrosion is the first method. Then the protective coatings, which includes inorganic and organic coatings, which covers the surface to be protected. Third is the cathodic protection, in which the metal to be protected is converted into cathode. Fourth is the anodic protection, which is very similar to the anodizing, and fifth is the corrosion inhibitors method, in which the inhibitors are employed to suppress the electrochemical corrosion. And the inhibitors are classified on the basis of their mode of action as well as the structure. So let us now discuss, beginning with the selection of materials and the design of the machinery. We all know that all the machineries are made up of small parts which are made up of metals. Therefore, metals plays an important role in determining the rate of corrosion. So if we take certain measures, we can prevent the electrochemical corrosion. The first thing is we should avoid the use of dissimilar metals in contact in the machinery, because it will lead to differential metal corrosion. Because the metal, if they are dissimilar, the one with the low reduction potential becomes the anode and starts suffering corrosion. But if it is unavoidable, then use of insulators can be made. But if we are using the insulators in between the dissimilar metals, then in such a case, the insulators should not be porous, such as asbestos or wood, which are very porous and absorbs moisture. In such a case, the corrosion becomes very intense. Also, all the parts of the machinery should be equally aerated and should be kept away from the dampness. There should not be any spaces or joint near the joints, because these spaces or the voids will trap the humid air, leading to differential aeration corrosion. All the metal parts which are used in the machinery should be subjected to proper annealing to avoid the stress corrosion. If two dissimilar metals are used, then the ratio of anodic to cathodic area should be kept greater than unity. And in case the surfaces are coated with paints or other metals, then the surroundings should be taken into account to prevent the electrochemical corrosion. Dust should not be allowed to deposit on the surfaces, because it leads to pitting corrosion. The sharp edges on the machinery should be avoided, and the machinery should be supported on the legs and not on the broad base. So if all these points are carefully managed, then the lifespan of the machine can be increased many folds. Therefore, we can say that the selection of materials and the design of the machinery plays a pivotal role in controlling the electrochemical corrosion. The second point is the protective coatings. If we want to control the corrosion by coating it with some other metal or paint, then such materials which are coated on the surfaces to be protected are called protective coatings. The protective coatings are of two types: inorganic coatings and organic coatings. Organic coatings will deal after completing the inorganic coatings. The inorganic coatings are the inorganic materials which are coated on the surfaces to protect them from the electrochemical corrosion. And they are of two types: metal coatings and surface conversion coatings. The metal coatings are the coatings of one metal such as zinc or tin on the other metal which is to be protected from the electrochemical corrosion. And such metal coatings are called anodic metal coatings or cathodic metal coatings. The surface conversion coatings are actually the conversion of the surface itself by the formation of a uniform, non-porous and passive layer of oxide, phosphate or chromate on its surface. And such coatings are called surface conversion coatings. We'll begin with the metal coatings. So I have already told that the metal coatings are of two types: anodic and cathodic metal coatings. When the metal which is coated on the surfaces to be protected are anodic, then these metal coatings are called anodic metal coating. For example, zinc when coated on iron forms the anodic metal coating because zinc is anodic to iron and the process is called galvanization. But when a coating which is cathodic to iron is coated on the iron, such as tin, then it forms the cathodic metal coating and the process is called tinning. Both galvanization and tinning can be obtained using hot dipping method. I will explain the anodic metal coating or galvanization first. So the coating of zinc on the iron, that is the base metal, is known as galvanization. Now we all know that zinc is anodic to iron. Therefore, it forms an anodic metal coating and the process is called galvanization. The galvanized sheets, when scratched, then the exposed area, that is the iron which is the base metal, gets exposed, forms a small cathodic area and the entire surface which is coated with zinc forms the large anodic area. Therefore, zinc protects the small scratched portion by sacrificing itself, and this mode of protection is called sacrificial mode of protection. And I have already explained under the factors the ratio of anodic to cathodic areas. So, galvanized sheets, if scratched also, does not allow the electrochemical corrosion to take place. The process of galvanization is explained in simple steps, where the sheet to be coated is first subjected to pre-treatment. Here, the iron sheets to be coated with the zinc are explained with the help of diagram as well as text. The iron sheets are first cleaned with the help of organic solvents. And then this process is called degreasing. The degreased sheets are then subjected to dilute sulfuric acid, and this process is called pickling. After pickling, the sheets are rinsed with water to wash away the excess acid from it, and then it is treated with the flux, which is a molten mixture of zinc and ammonium chloride. And then it is passed through the molten zinc kept at 450 degrees centigrade. After passing through the molten zinc, it is passed through the rollers and a blast of air is blown to get rid of excess zinc. And now the galvanized sheets are ready for commercial use. Tinning or the cathodic metal coating is similar to galvanization. Here, the iron sheets are first degreased, then subjected to pickling, after which it is rinsed with water, dipped in the flux and coated with the tin. But if on the tin sheet a small scratch appears, then the small scratch forms the anode and the large surface area of the tinned plate forms the cathode, which leads to intense corrosion, which is nothing but the pitting corrosion, leading to formation of holes on the metal surface. Therefore, if we are using the tinned sheets, we should use them very carefully so that they should not get any scratches. The process of tinning is similar to galvanization. Here in this method also, the sheets to be tinned are first subjected to pre-treatment, that is, treating with the organic solvents by degreasing it, then subjected to pickling, that is, dipping in the dilute sulfuric acid, after which the sheets are rinsed with water to wash away the excess acid, and then subjected to flux treatment, which is immersion in the aqueous solution of zinc and ammonium chloride. After which the sheets are dipped in the molten tin, maintained at 450 degrees centigrade in the bath. After dipping in the tin solution, the sheets are passed through the palm oil. The palm oil prevents the oxidation of the coated tin. And then it is passed through the rollers as shown here in the figure to remove the excess tin, and now the tin sheets are ready for commercial use. Let us now compare the two processes of galvanization and tinning. Galvanization is coating of zinc on the iron, whereas tinning is coating of tin on the iron. Galvanization protects the base metal by itself undergoing corrosion, whereas tinning, if gets scratched, leads to intense corrosion. And it depends upon it can be explained with the help of the area of anode to cathode. The galvanized sheets cannot be used for storage of food because zinc is toxic in nature, whereas tin sheets are widely employed in the packaging of foods as cans. The remaining methods will be continued in the upcoming videos.